All right, everybody. Welcome to the fifth video in the series. Hopefully you made it this far. We're going to do problem 5.62, which is another problem recommended by the course director. This is also the general problem dealing with pulleys, and if you're anything like I was in my first year of physics, I hated pulleys. Some people get it right away, others like me had to really think about it for a long time. All right, so to describe the problem, we have two pulleys, 1 and 2, where one pulley is being held by a chain, and another pulley is handling a weight we're going to call W. The rope is attached somewhere in the ceiling, and the rope is being pulled by some force F down here. And the problem wants you to figure out what is the force in terms of the weight, and how much force is the chain putting on pulley number 2. Alright, it tells you that the system is in equilibrium, meaning nothing is accelerating. So you know that this is a sum of forces equals 0 problem. All the forces are in the y, so there's nothing too much to do in the x. The next thing you have to realize is you have two bodies, and each one of them deserves its own body diagram. So let's start with pulley 1. It has the weight W going down, and it has two forces going up due to the rope. Remember, the rope can only pull, so here it is pushing the pulley up, and here it's pushing the pulley up as well. Now the next concept you need to know or remember is that the tension throughout the rope has to be constant, meaning the tension here, here, and here are all the same. And if we call this force F, which we're pulling with, in other words, we have 2 times the F going up and the weight coming down. For the second pulley, we have the force of the chain, we have the force from the rope, 2 of them coming down, since they're both pulling down at this point. The problem, I should have mentioned, the problem said that the pulleys themselves were weightless, that the chain was weightless, so I don't have to worry about those two. Alright, so if I do the sum of forces in the Y for body 1, I get that 2F minus W is equal to 0. And for the other one, F of chain minus 2F is equal to 0. And up until here, I'm done with all the physics. Now I just have to do algebra. And we get that the force from the rope required to keep this whole system from falling down is equal to the weight over 2. And that the force from the chain is twice the force in the rope, and it's equal to omega. I'm sorry, to W. And that's it. Alright, to summarize. First, I realized this is a sum of forces equals 0 problem. It's an equilibrium problem. I read carefully that the pulleys do not have weight, so I don't have to worry about that. The next concept is to know that the tension in the rope, its magnitude is constant all throughout. Then I have to do a body diagram for each body. For body 1, I know the weight is pointing down, but that the rope here is pulling at these two location, so I have to have two forces going up for body 1. And now for pulley 2, they're pulling down, not pushing, sorry, pulling down. And then I set up the equations for sum of force in the y equals 0, and solve for the algebra. All right. I hope that was useful.